Hello, welcome. My name is Faisal from Phoenix Academy. In this lecture, we are going to learn about how to create a Python script that will enable us to carry out an ARP spoofing. An ARP spoofing is a form of man-in-the-middle attack in such a way that we have the attacker staying in the middle of the connection between two communicating parties, say M and N, and the attacker intercept the packet that one of the communicating entity is trying to send to the other entity, and this will enable the attacker to view the packet and perhaps even modify the packet. Though we have a tool in Kali Linux, ARP Spoof, that enables such type of attack, but we are going to create our own tool to enable us exercise our Python programming skills and to better examine how this ARP spoofing works. Okay, so let's know about the IP address of our Kali Linux machine. We know the IP address of our Kali Linux machine, ifconfig. When we file this command, we're able to know the IP address of our Kali Linux machine. We can see the IP address is 192.168.43.201, and then this is the other machine that we want to carry out the attack on, and then we can know the IP address of this particular machine by also passing this command. This is a Windows 7 machine. ifconfig. Okay, sorry, ifconfig. This is the IP address of the machine, 192.168.43.225. So we can see they are on the same network. Okay, so now we are going to go to our PyCharm and then create the script and then see how this tool works. Alright, so I've already created a project, ARP Spoof. So let's get coding. Now this first line of code is what you call a shebang. Now a shebang designates the Python version we are going to use to run our script. So we have just designated Python as the script, as the interpreter that we are going to use to run this Python script. So by this, it means that the default Python interpreter on the machine that we are going to run this script will be used to run this script that we are creating. So in essence, what I'm trying to say, you can add Python 2. When you say Python 2, that means Python 2 will strictly be used, even if the default Python version on that particular machine is not Python 2, so Python 2 will be used. And if you write Python 3, that means Python 3 will be used. However, if we leave it at just Python, then the default Python version that is on that particular machine will be used to interpret this script that we are creating. So I know that I'm on Kali Linux machine and the default Python is Python 2, so that is why I am free to just write straight ahead Python. Just as if you come to your terminal, when you type just Python, it will take you to the Python interpreter, Python 2.7, which is the default Python version of Kali Linux. So that means Python 2 will be used to run this particular script that we are creating. Okay, so the next thing we do, we import the modules that we are going to use. Import skp.all as skp. Okay, as skp. Good. So here I imported a module called skp.all as skp, and a module is just a package that contains functions and classes that we may require in our program. So we are going to require some functions and some classes from this particular module called skp.all. and we will reference it throughout the program as Skefi. That is why I wrote it as import Skefi.all as Skefi. So throughout the program, we are going to reference it as Skefi. Now the next module I'm going to require is time. So I also imported another module called time. We are going to make use of the time module in this particular script that we are creating. Okay. Then we import another module. Import sys. Sorry, the machine is freezing. It's hanging. Okay, so I've imported another module called sys because we are going to make use of some functions from the module sys in this our program. So next we import so here I also imported another module called arpspoof. Now we are going to make use of some function within this particular module within this our program. arpspoof. Okay, it's a typo. Model arpspoof. All right. Now the next thing we do, we are going to create a function. And a function is just a unit of a program that carries out a particular function. It may return a value and it may not return a value. So we are going to create a function called get IP. Get IP, and this function will be solely responsible for getting the IP address of the target machine and the gateway from the command line. So the user of the program will enter the target IP address of the target machine we want to spoof, and then the gateway. Okay, you enter both their IP addresses over the command line, and then this function will be solely responsible for getting those target IP addresses and then giving it back to our program. Okay, so I've declared a function called get IP. The def, the def keyword, is a keyword used in declaring a function in Python. Okay, so parser equals to arpspoof. Argument Faisal. Okay, now the next thing I did, I create an object of class parser. So argument Faisal is a class from the module arpspoof. Now I created an object of it and then I assign it to the variable parser, so that now parser will have access to all the functions and variables of this class argument parser. Okay, then next we add options. And basically what this argument parser, class argument parser, does is that it enables us, it pass over the command line to enable us get the values that the user of this particular program is going to enter over the command line. Okay, so let's proceed. Alright, so line number 11, I invoke function add argument, which is from the class argument parser. I'm so free to use it because I've already created an object of this particular class argument parser. So parser is an object of class argument parser, as we have seen in line number 10. So I use that particular object to invoke function add argument, and this function add argument will enable us to add an argument that the user will supply its value over the command line while executing this particular script. And one of those argument is target, which the user of this particular script will enter its value using the -t switch, or we call it flag, or the -- target flag. And then the particular value that the user is going to enter, it is going to be stored in variable target IP. That is why we have this argument dest equals the target IP. And if the user fails to supply a value for this particular variable target IP, then the program will output this particular help message, specify the target IP address, prompting the user of this particular script to enter the target's IP address. Okay, so the next line number 12 is also similar to line number 11. It's prompting the user will make use of the -g or dash gateway flag to enter the value for the gateway, to enter the gateway's IP address, which will be stored in variable gateway IP. And if the user failed to supply the value for the gateway IP address, then this particular message specify the gateway's IP address is going to be outputted, prompting the user to enter the gateway's IP address. So let's proceed. So line number 13, I invoke the first ask function from the object parser. And basically what this function will do, it will pass over the command line and then get the values of the argument that the user supply over the command line, that is the target IP address and the gateway IP address that the user is going to enter. And this particular function first ask will get the value and then assign them to variable options. That is just what this first ask function does. Let's proceed. Now in line number 15, we make use of the selection control statement if, and then we make use of the negation not to check for when the user does not enter the the target IP, the value for the target IP. So we want to prompt an error message asking the user to enter the IP address. All right. Okay, so we are going to issue out this error message asking the user to enter the help command for more information. And when he enters the help command, then actually this particular menu specify the target IP address and specify the gateway IP address is going to be outputted to him to guide him on how to go about using this particular script efficiently. Okay. So let's check for when the user does not enter the gateway IP address. And if not, options dot gateway IP. Faisal dot error. All right, let me go with it, please. Is by an IP address for the gateway. More info. Okay, so line number 18 will output an error message asking the user to enter the gateway IP address when he failed to do so. And then finally we return options. So options will actually contain only the value of the target IP address and the gateway IP address. So any line of code calling options get IP will get the target IP address and the gateway IP address. So let's proceed. Now next we define another function again. Get MAC. Now we have gotten the IP address for both the gateway and the target machine, but we still need the MAC address to spoof an ARP response packet. Okay, so we need a function get MAC will help us acquire the the MAC address of the target and the gateway. Okay, so and we are going to supply IP address to it as a parameter. All right, ARP header equals to skippy dot ARP pdest equals to IP. Okay, so line number 24 we created an ARP header. So just basically this ARP header is just an object of class ARP. So an ARP is a class within Skippy that will enable us create an ARP request. And we all know address resolution protocol. Address resolution protocol is a protocol that enables machines within the same subnet get one another's MAC address, because MAC address is used within a subnet for communication, not IP address. So a one machine wanting to communicate with another machine has to know that particular machine's MAC address. So they use this particular address resolution protocol to resolve the IP address to MAC address so that they can use the MAC address for communication. So we create this ARP header, which is basically an object of class ARP, and it's an ARP packet to enable us carry out that request. And this PDST, the PDST field of this class ARP will enable us to specify the IP address, the IP address of the machine that we want to send this particular ARP packet to. Okay. One, two, three, 4, 5. All right, my bad. 6. All right. So line number 25, we created an ETA header. Now ETA header enable us to enable us to specify or create an ETA packet. Now ETA packet will actually be responsible for now transmitting the ARP packet, help us specify the destination MAC address where we want to transmit this particular ARP packet, this custom ARP packet we are creating. We specify the destination MAC address as the broadcast MAC address, which is the FFF we wrote here, and the value of the DST field of class ETA. Now this means that this particular the destination of this particular ETA packet is a broadcast packet. That means all the machines on this particular subnet will have a copy of this particular packet that we are creating. Okay. So ARP request packet now. This line number 26, now we have a complete ARP packet, a complete address resolution packet. We have the ARP request, and then we have the ETA packet, which specify the destination of the ARP packet where we want to send it. And using the DST field of class ETA, we have specified the broadcast MAC address. That means all these stations, all the machines within this subnet will have a copy of this our ARP packet that we are creating. So now joining these two, ETA header and ARP header, enable us to create a complete ARP packet. All right, so line number 27, we making use of the SRP function from class KP. We now make use of that particular function to now send out this particular ARP request packet that we created in line number 26, and we specify the timeout, the parameter timeout. We assign it with the value 1. That means that on reaching the any particular machine within the subnet, it will just wait for 1 second to get a response from it before moving on to the next machine in the subnet. And we set the verbose parameter value to false, meaning that we just need the necessary information. We don't need any verbosity. We don't need much detailed information. We just need the required information, just the minimum amount of information. That is why we set the verbose parameter to false. Okay, and then what SRP function actually returns 2 lists. It will return 2 lists to us. One of the lists is a couple, which comprises also of 2 lists: the packet we sent, the ARP request packet we sent, and then the answer we received, the response we received from the machines on the subnet, while the other lists contain the unanswered packets. Okay, so answered list, we are now trying to assign, we want to assign only the first list, which is a couple comprising of packets sent and the response received to our answered list. So I will actually add index 0 to specify that. So actually only now the first list will be assigned to our variable answered list, and that list is a couple comprises of the packet that we transmit asking for MAC address, the ARP request packet that we transmit, and then the response we receive. This will be assigned to variable answered list. So for further information, you can go to the documentation of the SRP documentation to find out about how this SRP function works. So in line number 29, what we do, we are going to return the MAC address. Okay, let me break it down. So we are going to return, we know that the answered list from line number 27 will contain the first list, which is actually a couple, the packet sent, the ARP request packet we sent, and then the response we receive from the stations that are up and that reply back to us with their MAC address. Okay, now that is why we specify answered list index 0, the first list, and within the first list, which is also comprising of 2 lists within it, we reference the second list, which is the response that we receive. So within those response, we want to extract the MAC address, because HWSRC refers to within that packet the field containing the MAC address of those within those response. That is why we wrote .hwsrc. So it will extract within those packet the MAC address of this particular response that we receive, of the packet that actually reply back to us with their MAC address. Okay, so let's proceed and create another function again. Def spoof. Target IP. Spoof IP. Okay, so this function line number 32 will actually perform the ARP spoofing for us. Alright, so let's go in and get code. So line number 3, we invoke function getMark, and we supply to it as argument the target IP address, the machine that we are going to spoof. We are going to perform the ARP spoofing on. We are going to perform the man-in-the-middle attack on. So we want to get its MAC address. So we call function getMark, and as argument we pass the IP address of the target machine. And when we get the MAC address, we are going to assign it to variable target MAC. Okay, so line number 34, we created an ARP packet. We create an ARP response packet. So how is it an ARP response packet? Because we specify the OP field to 2. Actually, by default, the OP field is 1, which is ARP request. But here we are creating an ARP response. And why are we creating an ARP response? Because this is one of the vulnerability of the ARP address resolution protocol, one of its vulnerabilities. So a machine can actually get a response from any other machine, even if it has not actually make an ARP request. So when it get an ARP response, it accept that particular response, and that is one of the technique used in man-in-the-middle attack. So we are going to the target machine to send it an ARP response when actually it has not make any ARP request, and that will enable us to spoof the MAC address that we want to. Okay, and the target machine will not even bother to verify whether we are the right machine that we are trying to spoof. So it will just accept our response and trust our response. So we send the OP field to 2 that we are making an ARP response. Unlike in the other ARP packet we created earlier, like a line number 24, we didn't specify the OP field as anything. We just create a normal ARP packet, ARP request packet. Okay, and we specify the destination FIDEST, the destination IP address, as our target IP address. So we are trying to pull that we are the one, the destination target IP. We want to send that particular response to our target IP, and hardware destination, and using its MAC address, since MAC address is the address that is being used for communication within a subnet, and we are trying to use this particular IP address. We are saying that we are the one with this IP address, that is the spoof IP address, that we are the one with this IP address. Okay, now the next thing we do, we simply send the packet. So skp dot send Okay. Path was equals to false. I think there's no any error here. Alright, let's proceed. So escapee.send. Is this an error here? There's an error here. Escapee.send. It's a function. I made an error. Yeah. Okay, let me go escapee.arp. Escapee.send packet bubbles false. Okay, good. So we can proceed. Okay, so now next I'm going to create another function again. This will be responsible for cleaning the ARP table after the response. Def restore destination IP. Okay, so line number at 9, I invoke the function getMark again, and I pass to it as argument the destination IP address and IP address that it will actually get its MAC address for me. Okay, bucket escapee ptest Okay, the computer is hanging a little bit. Destination IP, sorry for that, the computer hanging is now okay. So hardware DST destination mark. Okay. PSRC, the FRC field. I'll specify it to the source IP, the source IP. Source mark. Okay. Source mark. Okay. So now in line number 41, I created an ARP packet, an ARP response packet. I specify the OFI field to 2, the destination IP, which is the destination MAC address, the destination IP address rather. I specify as the destination IP, the MAC address, also the IPs, the machine that I'm going to send this packet, its MAC address, then the IP address PSRC as I pass it as I assign it with the source IP, then the HWSRC, which is the MAC address, source MAC. So in essence, this particular packet is trying to clean the ARP table that we have poisoned. It's trying to send the legitimate MAC address and the IP address. So in essence, it's trying to connect those two entities that we sat in their middle. It's trying to establish a proper communication between those two entities that we sat in their middle to eavesdrop on their communication. So there's no any form of spoofing in this particular packet in line number 41. Okay. 42. Next, we send the packet skp.send say packet count Okay, now finally we send the packet, and the count of 4 means that this particular packet is going to be continuously sent 4 times to ensure that we have achieved what we are trying to achieve. We have achieved our purpose of cleaning the ARP poison that we have created as a result of sitting in the middle between those 2 communicating machines. And then we set the verbose parameter to false, that we don't want any redundant information, any extra information. We just want the minimum amount of information to make the we just want this particular function sent to achieve its purpose. Okay, so so far these are the functions that we need to achieve this particular program. Now the next thing that we do, we go into the main body of the program. Now I created a variable options, get IP. So the first thing, line number 45 is the main marks the beginning of the main body of the program, and this particular line number 45 we actually get the IP address, the IP addresses of the target machine and the gateway from the user, as we have seen earlier when we created the get IP function. Okay, so line number 47, try. Make use of the try, which is a mechanism for exception handling, to make sure if there is any error, we handle the error. So the code in the try block will attempt executing, and then if there is any exceptions, we use the except keyword to handle that particular exception. So all the codes now under the try block will try executing, will be executed. Okay, so let's proceed and see what goes on. So while and actually in line number 48 we just created a counter, send packet count, which will keep track of the number of packets that we transmit. So line number 48 is just a counter, send packet count is a variable that will keep track of the number of packets that we transmit. And the line number 49 we created what we call an infinite loop. An infinite loop. So this loop will continue running, it will run forever, because there is no any condition, because there's no any time this condition will evaluate false and then the loop will stop. So this loop will continue running infinitely. But let's proceed and see how we will go about stopping this particular loop. Okay, sorry, it's a little typo here. Target options, the target IP. Sorry, alright, it's supposed to be gateway IP options dot target IP options dot gateway IP. Okay, so line number 50 we call the spoof functions, and we pass on to it the target IP and the gateway IP. So it will actually go out and carry out this spoofing. It will fool the the victim machine that we are trying to target. So it will fool it into believing that we are the gateway. So now we need to resend another spoof packet again, fooling the gateway that we are the target IP. So we have to actually send this particular packet again. So I can just duplicate this particular line by just pressing Ctrl D, and then it will duplicate. Just click on it and then press Ctrl D. Sorry, my computer is hanging, I don't know what's going on. Okay. Alright, so I have successfully duplicated the line. Alright, there's a little typo. Options dot Alright. Still experiencing issues. Options.gateway IP. Target IP. Options.gateway IP. Alright. And then options.gateway IP. Okay, this is not there. options.gateway IP, options.target IP, options.get. Okay, so we are good. Yeah, everything is all right now. Okay, so next we send the packet. Okay, no, we update our counter since we have sent 2 packets. So we are going to update our counter with the number of the packets that we have just transmitted. So send packet counter, send packet count plus 2, since we have transmitted 2 packets, a line number 50 and line number 51. So send packet count is just a counter that will keep track of the number of packets that we transmit. Now let's just print out a message. Print. Now this is an escape sequence, which perform the function of just carriage return. We are going to explain it. Let's see how it works. All right, print out this message. Packet sent. Packet sent. A colon like this. All right. Actually, I don't need this comma, so I'll just make use of a concatenator and str. Okay, send packet count. All right, and then load the string. All right, so line number 53, I'm trying to print out just a message which will notify the user of the number of packets that have so far been sent. So the carriage return will erase the previous printout. It will erase the previous printout and bring my cursor to the beginning of the line, so that a new printout will replace the previous printout. That is what this escape sequence /r does. Carriage return. So it will just bring the cursor to the beginning of the line, and this will erase the printout, and then the new printout will take place of the previous printout. Okay, and we have a comma at the end of this print statement. Now this will ensure that we don't print a new line, and if we don't print a new line, the printout is going to be saved in a buffer, so we won't actually see any printout. So to make sure that we actually see a printout, we are going to make use of a function from the sys module that we imported. So we are going to make use of this particular function to make sure that we actually what is actually stored in the buffer is actually flushed out, so that we'll see it. So I'm going to make from the sys module, from this std out, there's a function called flush. Okay, so unfortunately the computer keeps hanging, so I'm going to make use of this function now to flush out what is in the buffer, so that it is actually print out immediately and the user of our program see it. Okay, now I'm also going to make use of time.sleep function. Now time.sleep function will make sure that our program make a delay for some 2 seconds before attempting to resend another spoof packet again. Now this will make sure that our network is not bombarded with so many packets, it's not overcrowded with packets. So it will just make some delay for some 2 seconds before attempting to resend the packets all over again. Okay, now after this, we created an infinite loop in line number 49. So this will continue running. This program actually will continue running. Now when the user of our program want to terminate this program, actually is going to press Ctrl+C, which stands for keyboard interrupt. And since this program has been created to run using an infinite loop, our program will not do not anticipate that the user will press this Ctrl C keyboard interrupt. So now, making use of the except keyword, we are going to notify this program that it shall accept keyboard interrupt. And when this keyboard interrupt, we want the program to run this code under this except block. We want the program to print this particular statement. A new line character. You print out a new line, and then I'm experiencing issues with my system. Keep freezing. The system keeps hanging. Oh, it's so embarrassing. Let me pause the video and then I'll resume. Okay, everything is in control now, so let's proceed. New line character. So we have a new line character. Start printing out the message. Alright. Then after printing out this particular message, now we clean the ARP tables by invoking the restore function. We invoke the store function, and then we pass to it as argument options target IP and options dot gateway IP. Okay, so we are trying to establish the legitimate communication between the two parties that were initially supposed to communicate with one another, not our machine that is sitting in between. So we are getting away from the communication between the two. We are trying to re-establish them so that the communication is between the target machine and the gateway, not between our machine and the target machine or between our machine and the gateway IP. So we need to actually resend these two packets twice again. So we invoke the restore function again, and then this time around we have options.gateway IP gateway IP and options dot supposed to write options. Yes, okay, so there's actually an error here. Options dot target IP and then options dot target IP. Target IP. Okay, so with this we have successfully created the particular Python script that will properly perform an ARP spoofing. So let's go ahead and run this particular Python script and see how it works. Okay, all right, the machine is hanging. Okay, let me pause the video and set it up. Okay, so we have successfully finished creating the Python script. Now the next thing, let's go to the Windows 7 machine. Now when we go to the Windows 7 machine, we can get the ARP table period to run the script. Let's get to know the ARP table. Okay, by running this command ARP -a, we can see the ARP table. We can see the gateway. This is the IP address of the gateway, and we see the MAC address of the gateway. This is our Linux machine, and this is the IP address of our Linux machine. Now when we run the ARP spoofing script, we will see that the MAC address of the gateway will be the MAC address of our Linux machine. Okay, so let's go back to the Linux machine and then we run the script. Okay, so I have the script. I created the project in the desktop and the folder called Python. So I'll navigate to that folder. So by issuing this command cd desktop. Okay, and then there's a folder called Python. That is where I have created the project. Python. Okay, ls. Then I will navigate to the folder where I have the Python script ARP spoof. Okay, ls ARP spoof.py. Okay, so now I'll attempt to run the script. Python ARP spoof.py. Then I'll have to supply the target IP address and the gateway IP address. Now the target IP address with the T flag. Now what is it? I can go to the Windows 7 machine, and then if I run ipconfig, I can be able to see the IP address of the Windows 7 machine. Now the IP address of the Windows 7 machine is 192.168.43.25. So I'll come over here and then I'll issue it 192.168.43.25. Okay. 25, and then the IP address of the gateway is 192.168.43.1. that is the IP address of the gateway. Okay, then I will press the enter command. Okay, while scanning the packet count. Okay, there seems to be an error in line 53. Packet sends string. Okay, let me go to that line and see what the error is. Okay, there's I added line 53. There's a quotation. I added a quotation that's not supposed to be there. So line number 53, I have to remove this particular quotation. It's not supposed to be there. Okay, I will save the script, and then I'll go back and run the script again. Okay, clear. Okay, so I have run the script. Okay, so I can see that our Python script is working perfectly. It's running. 8 packets have been sent, and they are on the same line. The newest printout is replacing the previous printout. Okay, now let me go to Windows 7 machine, and then you can see the IP address of the gateway. It ends in E3, B6E3. So now let me go back and run the ARP-A command again and see. Okay, we can see that the MAC address of the gateway has changed to the MAC address of our Linux machine, which has this IP address 192.168.43.201. I can see that. So the gateway now is having the MAC address of the attacking machine, Linux machine. So our ARP spoof has worked successfully. However, when this particular machine attempts to go to the internet, it might encounter some issues. When we attempt to browse the internet, okay, let me window this Firefox, the browser. We might encounter some issues. So we have to go because when the packet flow through our Linux machine, the firewall in the Linux machine will drop the packet, because under normal circumstances our Linux machine is not acting as a router. So to enable packet flow through our Linux machine to the gateway, we have to enable what we call IP forwarding. So but let me demonstrate it. First of all, let me open this browser. The browser has freeze, otherwise let's open the Windows 7 browser and attempt to go to the internet and see what happens. So it's freezing. Let it on hang, then we can attempt to go to the internet, and then the Firefox browser. Okay, let me just pause the video and then I'll come back again. Okay, so welcome back. So in essence, what I'm trying to say is that when you come to the Windows 7 machine, when we attempt to go to the internet, the packet will be dropped, because when it follows through our Linux machine, the packet is going to be dropped. So what we have to do, we have to come and enable IP forwarding in the Linux machine. So we have to enable IP forwarding, so that the packet, when it follows through the Linux machine, it will go to the router and then it will follow to the internet. Okay, and we can do so by issuing this command. You say echo 1, then I'm going to fork sys net IP version 4 IP forward. Okay, so now when we after running this command, a packet can now flow successfully through the Linux machine out to the internet. So when we come here and run this command, you see that it can with the target machine will now have internet access. The internet connectivity is slow, that is why, but you can see that the Windows 7 will now have internet connectivity. It can connect to the internet. Okay, so when the Windows 7 has now successfully been able to connect to the internet, only that the connection was slow. Okay, so also when we come here, we have already seen how the ARP table become altered due to the ARP spoofing. Okay, so now let's go and stop the script and see how the ARP table will be restored. Okay, so let me exit this. So Control C to exit. So I've exited the application. So now let's go back and run the ARP-A command again, and then see how the ARP table become clean. We can see successfully the ARP table has returned to normal. Our gateway IP address has its normal MAC address. Okay, so this marks the end of this lecture. Thank you. Please make sure you subscribe, hit the subscribe button to get the future lectures that I'm going to release. Thank you very much.